The sun was once eerily quiet for 70 years, and scientists believe that a nearby star could explain why that happened. On a long enough scale, our sun is rather predictable. Roughly every 11 years, it goes through a solar cycle of high and low activity, the latter characterized by an uptick in sunspots, flares, and coronal mass ejections when it has high activity. On a cycle-to-cycle basis, it can be hard to predict how much activity our sun is going through or will go through, but there's always an increase in maximum sunspot activity and a decrease back down to minimum. Almost always. In the 17th century, the sun went through a period in which almost no sunspots appeared at all. From 1645 to 1715, this period encompassed several solar cycles and is known as the Maunder minimum. Maunder, M-A-U-N-D-E-R. This strange irregularity has long perplexed scientists, and now another nearby star could finally have the answer. It appears to have gone into a similar period of dormancy, and watching what it does could help us figure out what the heck is going on with our sun and what it's up to. We don't really know what caused the Maunder minimum, and we have been looking to other sun-like stars to see if they can offer some insight. This is what physicist Anna Bohm, formerly of Pennsylvania State University, now at Lehigh University in Pennsylvania again, of course, says. She says, "We have identified a star that we believe has entered a similar state to the Maunder minimum. It will be really exciting to continue to observe this star during and hopefully as it comes out of this minimum, which could be extremely informative about the sun's activity 300 years ago." The solar cycle is based on the sun's magnetic field, generated by the action of a dynamo process in the stellar interior, and every 11 years the solar magnetic field flips, with its north and south magnetic poles switching places. Can you imagine? Astronomers have observed sunspots from about 1610. It included Galileo Galilei observing the sunspots on the sun, and the first solar cycle on record started 1755. The solar minimum, characterized by a minimum level of sunspot and flare activity, marks the end of one cycle and the beginning of a new one, and it occurs when the sun's magnetic field is at its weakest. This is because the sun's magnetic field controls its activity. Sunspots are temporary regions of strong magnetic fields, while coronal mass ejections and solar flares are produced by a release of energy when a magnetic field lines trap, snap, and reconnect. So as the magnetic field strengthens, it stands to reason that there would be an increase in solar activity. Other stars have been observed exhibiting spot activity as well, although our records of these stars don't go nearly as far back in time. Bohm and her colleagues collected data from multiple sources for several decades worth of star spot activity for 59 stars. Out of these, 29 stars showed clear star spot cycles, similar to what we have seen in our sun, and of the remainder, some showed no star spot activity at all, suggesting that they may be rotating too slow for a dynamo process, and for some there was simply not enough data to make a ruling. And of those 29 stars, one was a standout, HD 166620, located 36 light years away from us. This star is about 80% of the size and mass of our sun, and around 6 billion years old compared to our sun, which is 4.6 billion years old. It also seems to have an active cycle about 17 years, yet has shown absolutely no sign of sunspots since the year 2003. Astrophysicist Jacob Loon, formerly of Penn State, now at University of California, Irvine, said, "When we first saw these data, we thought it must have been a mistake, that we pulled together data from two different stars, or there was a typo in the catalog, or the star was misidentified," he said. "But we double and triple checked everything. The times of observation were consistent with the coordinates we expected the star to have, and there are not that many bright stars in the sky that Mount Wilson observed. No matter how many times we checked, we always come to the conclusion that this star has simply stopped cycling. This means it could also be experiencing a Maunder minimum, Vexingly, the star of this low activity period occurred during a gap between observations of the star, but continuing to observe the star throughout its low activity period could help shed light on our own sun's weird activity. Baum said, there is a big debate about what the Maunder minimum was. Did the sun's magnetic field basically turn off? Did it lose its dynamo? Or was it still cycling but at a very low level that did not produce any sunspots? We can't go back in time to take measurements of what it was like, but if we can characterize the magnetic structure and magnetic field strength of the star, we might start to get some answers. And this in turn could help us get a better handle on solar weather, space weather that is, which has important implications for our Earth and the rest of the solar system, and it could help us better understand how stars work, what drives them, and what goes on in their mysterious hearts. Their insides, that is. This is published on the Astronomical Journal, and it's on Science Alert by Michelle Starr. Please leave your comments, and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.